Dr. Michael Grose is a climate projection scientist at CSIRO. His research focuses on climate projections and communication for Southeast Asia, Southeast Australia, as well as climate model evaluation and making projections for Pacific Island nations. Michael is a lead author of the State of the Climate Report, which we're discussing tonight, and also lead author for a chapter of the forthcoming Intergovernmental Panel on Climate Change's sixth assessment report, which I think is a very impressive feat, achievement. So Michael also regularly communicates on the latest climate science in activities such as on the conversation and via public speaking engagements. As I mentioned, tonight Michael will take us through the latest State of the Climate Report, which was released in November 2020. Co-developed by the CSIRO and the Bureau of Meteorology, this sixth biannual report draws on the latest climate research encompassing observations, analyses and projections to describe year-to-year variability and then longer-term changes in Australia's climate. Observations, reconstructions and climate modelling are discussed in the report, and they paint a consistent picture of ongoing, long-term climate change interacting with underlying natural variability. The report also explores associated changes in weather and climate extremes, such as extreme heat, heavy rainfall, coastal inundation, bushfires, as we've seen recently, and drought, which have a large impact on the health and well-being of our communities and ecosystems. So without further ado, on behalf of YCAN, I extend a very warm welcome to you, Michael, and look forward to your talk tonight. Over to you.
Thanks very much, Catherine, and thanks, Andy, for that introduction, and thanks very much for the opportunity to come and speak to you tonight. And yeah, I kind of barely need to introduce the topic. It's been very well introduced. Yeah, the State of the Climate Report from 2020, joint production from the Bureau of Meteorology and CSIRO. So I know this is a very engaged and knowledgeable group, so I hope you'll have some very tough questions, and let me know if any of the content is too kind of, I'm going too slow or anything like that. So starting with some of the key messages about the report. So it's biannual, released every 2 years, draws on the latest climate monitoring from the Bureau of Meteorology, from all their weather stations and more, but also the oceans and monitoring that CSIRO does. The research and also looking at climate projections to describe the long-term changes in Australia's climate and put recent climate events in a long-term context, importantly. So it draws heavily on the work done at Bureau of Meteorology and CSIRO, but also draws on the best available peer-reviewed information elsewhere with an Australian focus. And I guess one big take-home message, if you had to say one, is that Australia is experiencing climate change now, with impacts being felt by many communities and industry sectors already. So the first section, I'll go through some of the kind of weather and climate statistics that you might be familiar with on land. So this is temperature, the fire weather, which is a big part of fire danger, rainfall, heavy rainfall, stream flow, tropical cyclones and snowfall. I won't go into all of these in detail. I'll focus mainly on temperature, rainfall and fire weather. So some of the key messages about temperature is that there's a warming trend globally and in Australia, and it's ongoing. And we've reported on this in previous State of the Climate reports, and it's just basically being continued. Through some new data analysis and careful reconstruction of temperature records, we now have an updated temperature record for Australia that's been able to better quantify the amount of climate warming that Australia has experienced with reliable measurements back to 1910. So since 1910, it's estimated that we've experienced about 1.44 degrees of warming, but there's a kind of uncertainty range or error bound around that in brackets, 0.24. And that's a little bit more than the global average in that time, and that's you might have heard of the figure 1.5 degrees of global warming being an important round figure. So I'll get back to that a bit later, but that's for the globe, and the globe is currently at about 1.1 degrees, heading towards that 1.5. So yeah, that 1.44 doesn't mean we're about to break that first threshold of the Paris Agreement target. That's the value for Australia, which is a bit higher than globally. And of course, rising average temperature means that we're getting an increase in the frequency of heat extremes and heat events, and a decrease in the odds of cold events and cold extremes. And temperature and other factors have come together to create an increase in extreme fire weather danger, including an increase in the length of the fire season across large parts of Australia since the 1950s, especially in parts of southern Australia. So here is a graph of temperature over the landmass of Australia, over land in orange, and in the surrounding oceans in blue. And you can see a very definite and clear trend in temperature in both the land and the ocean. And you can also see the large variability year to year that Australia experiences, including Australia's hottest year on record, 2019, and then 2020. Since then, I'll comment on a bit later. So how the change in the average temperature affects how we experience temperature extremes can be viewed in a couple of ways. And I think this is a really interesting and powerful way to show it if you can kind of get your head around how this graph works. So along the bottom is kind of a measure of cooler than usual, warmer than usual for Australia as a whole. And then up the scale is the frequency of occurrence. So this is kind of like a bell curve or a distribution graph, like you might have seen for describing where things sit, with very cool, very rare, and very hot, also very rare, and most things sitting in the middle. And a shift in the distribution to the left or the right, to the change in the average, leads to a big difference in where the tails are. So, sorry? I think there might be, it's okay? Okay, I'll just push on. Let me know if something comes up. So the orange curve there is the 1960s to the 1980s, and then the darker reds curves are 1990 to 2004, 2005 to 2019. And you can see there's been that persistent shift to the right. It reflects a change in the average, but you can also see the effect then of the change in what we call the tails, the hot extremes, where something that used to occur almost about 2% of the time is now occurring more than 12% of the time. So that's where you get a change. 1.44 degrees doesn't sound like very much, but when you turn it into what happens in the extremes, it looks very notable indeed. So 2019 was Australia's hottest year on record since records began in 1910. And this is also reflected in the temperature extremes experienced during that year. So this is a measure of the number of days when the Australian mean temperature was in the top 1% of the records, or the top 1 percentile, if you kind of know that terminology. And you can see that in the early part of the 20th century, we had very few days in that category. Obviously variability, ups and downs, not every year is warmer than the last, but there's a persistent and ongoing trend towards greater temperature extremes. And then 2019 sticks out like a sore thumb as being just extraordinary. In terms of rainfall, here is a kind of a map showing a colour scale of where temperature in the recent period, in the 2000s to 2019, where the kind of wet season or cool season in southern Australia was, compared to the entire record, was average or below average in red colours or above average in blue colours. And you can see almost all of southern Australia has been in its below average in the last 20 years compared to the whole record, and a lot of it has been the lowest on record since records began in 1900 for rainfall. There's some exceptions to that, like Western Tasmania, but much of Southwest Australia and much of Southeast Australia has been very dry in the last 20 years. You can see that also in a graph through time. So this is Southeast Australia in that same April to October or wet season, cool season kind of rainfall period. And you can see a lot of ups and downs, but in the recent period, there's been very few very wet years and a lot more of the dry years, including the millennium drought period, and then broken perhaps slightly by the kind of wet times in the 2010s, but then ongoing occurrence of a lot of dry years. And sometimes it's the lack of very wet years that has the biggest impact, because then you don't get the chance to really recharge and refill dams, etc. So it's not only just the average, but it's also the lack of wet years that has the impact. In southwest Australia, in the same season, it's even stronger, where you can see very few wet years since the 1970s, and very much an ongoing downward trend there. And this has got a very clear signal due to human influence on the climate. It's a very clear effect that's already been drying because of climate change and will projected to continue drying in the future. Looking at Northern Australia and Northern Australian wet season, there's a big contrast. Much of Northern Australia in the wet season in the last 20 years has been wetter than average. It's very variable year to year and decade to decade, but taken as a whole, the last 20 years has been above average for much of the wet season for much of Northern Australia. And this has also been linked to increasing in cloudiness and also some heavy rainfall events as well. State of the climate ever reported up until the end of 2019. So now that it's 2021 and we can look back on the year 2020, probably interested, how does 2020 compare to 2019, the record record dry and record hot year? And you can see this as anomalies or kind of differences from average for the bottom row, 2019, and the top row, 2020. On the left is rainfall, and on the right is temperature. And you can see 2019 sticks out very strongly at the bottom row there, with a lot of areas in red, driest on record, and a lot of areas in orange on the right, hottest on record. 2020 was not as extreme, as you probably noticed, but it was still a warm year. A lot of the country was in the above average or very much above average category, but of course it didn't break the 2019 record. The bushfires, of course, were on everyone's mind after the summer of 2019-20, and we've got some commentary about that in there, but what we mainly seek to do is to put that in a longer-term context. So a bad year comes along from time to time, but if that comes along on top of an ongoing increasing trend, then that makes the effect so much worse. Whereas if you've got a downward trend, then a bad year coming along is offset by that downward trend. And what we're seeing in terms of fire conditions is bad years, good years coming along, but because of an increase in the average or underlying climate, then the bad years are so much worse, and the not so bad years are worse than they used to be. So this is the trend since 1950. The difference between 1950 to 1985 and 1985 to 2020 in the Forest Fire Danger Index, the number of dangerous fire weather days measured by that index. And you can see almost everywhere, there's a little bit of patchiness, a little bit of kind of noise there, but almost all of Australia has experienced an increase in the number of dangerous fire weather days, and some areas with quite a dramatic increase in days per year, including up over 20 days per year more on average. And so that means that 2019, when it came along, the climate has already changed its state and made those kind of chances, those bad years much worse. So that covers the first half of what we wanted to talk about, Catherine. So perhaps stop for questions or comments or things there.
Thank you, Michael. And we've already got a couple of questions. The first one is relating to your slide around the additional heat in the atmosphere from climate change. And Shane asks, what proportion of the additional heat in the atmosphere for climate change stays in the atmosphere? And then what proportion is absorbed by oceans? And how stable has the proportion absorbed by the ocean been over time?
That's a really good question. And we're going to get to a topic like that in the coming slides, but maybe I'll just kind of cover it now since it's been asked. So yeah, the greenhouse effect is an imbalance in the radiation between the top of the atmosphere and the Earth's surface, and it kind of leads to a trapping of heat in the climate system. Water can store a lot more heat than air can because it's a thick fluid, and so a lot of heat goes into the ocean and then is stored there, and it can be transported to the deep ocean. So we report on the latest research, drawing on the latest measurements, putting it at about 90% of the extra energy trapped in the climate system goes into the oceans and is stored there. And that leads to a large increase in the total heat content, what we call in the ocean. And what doesn't go into the ocean remains in the atmosphere, or some of it also goes onto land, and also contributes to melting ice as well. And we put an estimate in, I can't remember the exact figure, but if the oceans weren't absorbing that extra heat and it all remained in the atmosphere, temperature increases would be extreme because the ocean wouldn't be there to kind of moderate and to absorb most of that heat. If it all stayed in the atmosphere, the temperature increase would be enormous. So yeah, the oceans are a really important and crucial part of our climate system, and an important thing to understand as we understand climate and climate change.
Hmm. That makes sense. Andy has a question. If temperatures in Australia have risen faster than the global average, is this likely to continue?
Yes, that's a really good question. So different areas of the world warm at different rates as kind of a greenhouse effect kind of kicks in. So you might have heard that the Arctic is warming at a rate much, much faster than the global average. The large continents of the Northern Hemisphere are warming at a rate faster than the global average. Australia is a bit higher than the global average. That includes oceans. That's at about 1.1 degrees since pre-industrial. But it's slightly less than the global land average. So it's not unusual for a land area. And oceans are warming up, the surface ocean is warming up slower than land areas, just for a few complicated reasons, but mainly to do with the processes between oceans and atmosphere and so on. So Australia has been warming up at a rate faster than the global average, but similar to or maybe slightly less than the global land average, and that's projected to continue. So that kind of ratio remains fairly consistent under future scenarios.
And then one more question for now, or I guess around the time frames for comparison. I think you mentioned deviation from like 1960 to 1990, and then also from pre-industrial times. How do you sort of, choose between the time frame? And would Australia now be more than 2 degrees warmer than pre-industrial times?
Yes, that's a really good question, and it is something we should be more clear about when we put up these graphs. Is we usually put them as relative to a particular baseline period. So a commonly used baseline period on a lot of things the Bureau of Meteorology have on their website is, for example, is 1961 to 1990, a 30-year period. I think it's getting a while ago now, but that's a kind of a good period. We've got good measurements and we can put things relative to that. There's a big interest nowadays in what things have happened since pre-industrial era, so the total change since humans have started influencing the climate. We don't have good measurements and good data right back to the start of the pre-industrial era, so it gets a bit tricky to look back that far. So people are kind of looking at a compromise period of 1850 to 1900 as kind of a rough approximation of what a pre-industrial climate might look like, because that was before industrialization really took off. And so there was already some change between that era and the baselines the more recent baselines we have more recently. And so for Australia, the 1.44 degrees was since 1910, where we've got reliable records. Prior to that, it's likely that there was some temperature change and some warming of perhaps 0.2 degrees since the pre-industrial era, but it's relatively small compared to what's happened after 1910. But it's more uncertain the further you go back.
That makes sense. Okay, well, I encourage everyone to keep asking questions in the chat function. In the meantime, let's continue, Michael.
Okay, thanks, Catherine. So I'm going to talk a little bit about the oceans and the atmosphere side of things. So this includes warming of the sea surface, and what I mentioned just before was ocean heat content, how much energy is stored in the oceans, and that is a big contributor to sea level rise. There's also the other carbon dioxide problem, which is ocean acidification, which is where carbon dioxide in the air, some of it becomes dissolved in the ocean, and that changes the chemistry of the ocean, and it can lower the pH, so acidify the ocean waters, and that causes issues as well. There's a section in there about the cryosphere, or the ice of the world, which is the big ice sheets of Greenland and Antarctica, the sea ice, the floating seawater around, frozen seawater around Antarctica and around the Arctic. I'm not going to go into that much here. And we've got a big section about greenhouse gases, so monitoring the atmosphere and the concentration of greenhouse gases in the atmosphere, because we've got a very important monitoring station in Australia, especially. So sea level has been rising globally at different rates in different places. It's important to kind of know that in some places it's rising faster than other places. But globally averaged, so averaged around the world, we've hit a kind of a milestone where global sea level has risen by around 25 centimetres since we can, reliably measure it, which is since about 1880. And the sea level rate of rise has been accelerating in recent decades. And this graph shows what we could estimate using tide gauges, which is measurements at the coast from gauges which go way back, but then more kind of detailed information we've been able to get from satellite altimetry measurements since the start of the satellite era. And they broadly agree, and they show that sea level rise is ongoing. There's a section in there about sea level rise around Australia, showing that it's rising in different rates around Australia. And not only that, but there's local effects to take note of. So at the coast, you might be having some kind of land rebound or local effects affecting how you experience sea level rise. And then also different coasts are vulnerable to sea level rise in different ways. So of course, sandy coasts can become eroded, whereas rocky coasts don't, etc. So yeah, there's a lot of issues around understanding sea level rise and its effects, and it is very different in different places. This is a graph of that metric I've mentioned a couple of times, ocean heat content. So this is the total amount of energy stored in the oceans, estimated through various ocean measurements. And you can see we've become more certain of that as we've gotten better measurements through time. Further back, it's a little bit less certain because we didn't have the measurements. But yeah, as we mentioned, around 90% of the extra energy is being stored into the ocean. And this change here is the change in ocean heat content measured in 10 to the 22 joules, which is zetajoules, which is a kind of extraordinary amount of energy. And it's equivalent, I think someone did a calculation a couple of years ago, it's the extra energy of 8 atomic bombs per second being stored in the oceans, that kind of level of energy. Because what we're talking about is a radiation balance of the entire Earth surface in watts per metre squared that's kind of operating 24/7. So and this is also a very steady measure of the change in the climate system. Temperature at the surface varies a lot year to year, up and down, but you can see, especially since about 2005, there's just a very steady increase in the total energy stored in the ocean. And this is a very reliable and kind of useful measure of the extra energy in the system, which is the driver of climate change. So in the atmosphere, carbon dioxide, of course, is a major long-lived greenhouse gas that we care about. Cape Grim in northwest Tasmania is one of 4 monitoring, globally important monitoring stations, and we measures CO2 all the time. But what's especially as important is to measure it when air is coming straight off the Southern Ocean, and it's called clean baseline air. So this is kind of the baseline measurement for clean air in the world. And this shows just baseline air since the 1970s. And you can see the increase is very steady. You can see a slight kind of upward bend to that line, and you can see that kind of showing that the rate has been increasing in the last 45 years. And you can see that more clearly by looking at the rise over each decade. So in the 80s, it rose by 14 parts per million. In the 90s, it rose by 16. In the 2000s, by 19. And in the 2010s, it rose by 23 parts per million. So that kind of shows you how that is increasing. And yeah, we've well passed the milestone of 400 parts per million in carbon dioxide in clean baseline air. And if you add up all of the greenhouse gases that kind of contribute to climate change, this is carbon dioxide, methane, nitrous oxide, halocarbons, etc., and turn them into the equivalent of carbon dioxide, so CO2e, we call it, that's passed the milestone of 500 parts per million. So yeah, and there's a little section in the report about the effect of COVID-19 lockdowns on greenhouse gas emissions, which is a big source of discussion when it first happened, and kind of giving you the big picture message that, yeah, it caused a blip in emissions, but that's a very small part of the total accumulated emissions that we've had over time, but it is interesting, and it's also interesting to see the effects of changes to other emissions, temporarily, like air pollution was slightly better for a little while in some places. Putting that in a longer term context, you may have seen plots like this before, but this is kind of the panel on the right putting it in the context of going back 2,000 years, and then the big panel putting it in the context of going back 800,000 years. And you can see it's unusual and much higher than any time it's been in the last 800,000 years, and likely at least the last 2 million years. In the kind of longer term plot with a very long time scale, you can see the cycles in and out of ice ages that the Earth experienced. And this is measured directly from the air trapped in ice cores from Antarctica. So this is where you drill an ice core, pull out the air bubbles, and measure what was in the atmosphere at that time. So it's a pretty reliable kind of measure. And yeah, that line, the dotted line going across the whole thing at about 300 parts per million, it never really got above that for probably at least 2 million years. And now we're way above that at about 400 parts per million in CO2. And not only that, the rate of change is very unusual over that whole period. So coming out of the last ice age, the rate of CO2 increase was about 10 parts per million per century. So it was rising rapidly, but recently we've been, it's been rising at a rate much faster than that, and has been increasing by 10 parts per million in just one decade, which is important for not just the total level, but the rate of change is important. So some key messages from this section is that global average concentration of all the major long-lived greenhouse gases continue to rise in the atmosphere, and we've now passed those milestones of 400 parts per million CO2 and 500 parts per million CO2e by 2019. I didn't kind of show a plot of it, but oceans around Australia are acidifying, and they have been warming as well. And warming of the oceans contributes to more frequent marine heat waves. So this is periods of elevated temperature, and these have a lot of impacts, including on aquaculture and ecosystems, and especially on coral bleachings. A big contributor to those. And the rate of sea level varies around Australia's coastlines, but overall sea levels are rising roughly in line with global trends, and we're now past that milestone of 25 centimetres. There's a small section at the back of the report about future and future projections, and a lot of these projections are for continuation of things we've experienced in the recent past. So global temperature rise to continue, sea level rise to continue, marine heat waves to continue becoming more frequent and more intense, warmer days with more heat waves and fewer cool days. Cool season rainfall is projected to decrease on average, but with a lot of variability and a lot of droughts and a lot of wet years still coming and going. But the overall trend for a decrease, especially in southwestern Australia and likely in southeast Australia. But in contrast, heavy rainfalls are likely to become more intense in most places, because that's just a function of a warmer atmosphere and how that operates. A longer fire season with more days of dangerous fire weather. Tropical cyclones are kind of an ongoing research topic, but the evidence so far tends to suggest that overall number, fewer tropical cyclones in the long run, but with a greater proportion of those being in the high intensity category. So it's not good news or bad news. It's kind of more bad news than good news. The decrease in the total number is of interest, but more in that high intensity category is important. And I'll just show this graph. There's a lot on this graph. It's kind of putting the historical temperature record in context of what could be experienced in the future, and shows a few things. So it's got the observations as a line, with the underlying kind of running average as a darker line, showing that 2019 was a really unusual hot year. The light blue band is what's simulated by climate models, one of the main tools we use to examine the climate and understand it and then make projections of the future. And then the orange band of those same models running into the future. And this shows that we got a fairly reliable view of the trends in temperature for Australia. And there's quite an agreement on a range of change into the future. And also it now shows that the temperature of each year is entirely above what we would have expected to be the range of possibilities in a pre-industrial climate. So that's the grey band down the bottom showing kind of the one standard deviation, or what range of change, and then the lighter band is the wider range of what we would expect. And now every year is higher than that entire range was, which is what we call climate emergence from the previous era. It also shows that 2019 was roughly about what we might expect to be a normal year, or an average year, if the world gets to around 1.5 degrees of global warming since pre-industrial. That kind of limit that's kind of specified in the Paris Agreement target. And if the world gets to something like 2 degrees of global warming above pre-industrial, then the average would be even hotter than 2019. An average year would be hotter than what we experienced in 2019. So that's trying to put that in the recent events in that perspective of what we see about projections for the future. So just to summarise the second part and the overall talk, I guess, is that climate changes to our climate affect all Australians, and we're seeing impacts, especially from heat events, fire weather, changes to rainfall patterns, changes in the ocean, and changes to the atmosphere. And the State of the Climate Report provides information to understand and start to think about it, adapting to climate change now and into the future. But of course, it needs a lot more detailed information and kind of discussion for what it means to you and to anyone in particular. So how about we stop there, Catherine, and go to some questions?
Great. Thanks, Michael. So we have a few questions. Let's start with a little bit of a curly question from Shane. If you were in control of Australia, let's assume a dictatorship here, what is the key measure you would adopt to address the climate emergency? Now, I know as CSIRO is a government agency, you can't comment on current government policy, but perhaps you could make a comment instead based on the evidence about which measures you think might be most effective.
Yeah, so I'm not an expert in emissions mitigation. That's the techniques and technologies and other changes we need to make to reduce greenhouse gas emissions. So all I would say is that any policy or any policy position has to listen to the evidence and stack up against the evidence. So any kind of policy position has to be justifiable given what we know, and it can't ignore that evidence. So it's not a dodge of the question, it's just kind of saying, yeah, I'm not an expert in policy or mitigation actions. So yeah, I don't think I would make a good dictator in that way. But yeah, I think it's just, yeah, any policy or any position has to listen to the evidence.
Great. And then also based on the evidence, you discussed the Great Barrier Reef. What chance do you think we have to save it?
So I guess, that's not really my area especially either, but there's also the question of what saving it means. Something will continue to be there in future decades. It just might be much different than it looks today. And it would be a real shame to lose a lot of the corals that are at risk from bleaching, and for those to then become, dominated by other types of species, or, seaweeds or sponges or things like that. So I guess it depends what you mean by save it. And I think save it in something like how it looks today, then I think, we would need to be onto a very low emissions pathway, and we need to really mitigate climate warming really rapidly, and I hope that can eventuate. And I think some of the changes we've been seeing recently, like some of the pledges the different nations have been making, and also some of the energy transitions that are kind of occurring, where like what looked like impossible 10 years ago now looks like it's inevitable. I think that's really important to keep in mind. Like, we used to think that coal was going to continue expanding, and it may have already peaked globally. So yeah, I hope we can get onto an emissions scenario that's kind of more consistent with 2 degrees, or ideally 1.5 degrees of global warming. But yeah, we'll just have to see.
And how much work does the Bureau and CSIRO do around tipping points? What are the greatest tipping point risks?
Yeah, so that's an interesting topic, and I think also that's kind of an issue of definitions as well. Like, people have different ideas about what a tipping point means, or runaway effects and so on. Some tipping points that people talk about are like where the ice of Greenland is now inevitably kind of going to be all gone, but it's just it's just in the process of going, things like that. I don't know a lot about it, and I know there's a lot of kind of uncertainties to a lot of them, because they're kind of quite interactions of complex systems and so on. So yeah, I can't really say much about tipping points, other than there's some really interesting articles out there about it. That I can point people to some if they like.
And then a question from Kate: what would the turnaround time be if human emissions stopped completely overnight? is it possible, and how long would the planet need to process and begin to revert the damage?
Yeah, so this is an interesting topic. Because people have got this idea that there's a lot of inertia in the Earth system, and if we stop tomorrow, then changes would continue for hundreds of years, and that's very much true. I mean, there is evidence that the global average temperature wouldn't rise that much more because other changes would offset the kind of some of the things that are locked in. But that kind of is just as a global average. There's still certain other things that are very much going to take a very long time to equilibrate. So regional patterns of change and sea level would continue for a very long time, even if emissions completely froze. Yeah, so it's an interesting kind of question. I mean, I think another interesting question is like, well, since that's not really plausible, what about a scenario where emissions peak and then we actually remove carbon dioxide? Could that kind of reverse things? On what couldn't it reverse? And there is some work on that in the IPCC 1.5 degree report about what kind of things, what's the effect of if we do kind of reverse the trajectory we're on and then actually go to CO2 removal, and what's the outcome of that? And some things, you know, obviously it's not that simple to just turn back the clock. Yeah.
Another question from Shane around our Pacific neighbours. So what are the key risks faced by our Pacific neighbours, and how do they differ from the risks faced in Australia?
Yeah, so of course the big one is sea level change and sea level rise for countries like Tuvalu and Kiribati, which have got a lot of low-lying coral atolls, where the highest part of some islands is only a metre. And so when people start talking about a metre of sea level rise, then those islands don't exist anymore. So that's obviously a huge one. I mean, any changes to tropical cyclones is, of course, also really important to the Pacific, because a tropical cyclone can just be devastating to a country for years if it gets really hit by a tropical cyclone, and they just have to build up their economy almost from scratch again. So yeah, in some ways, it's got some similarities, like heat and heat extremes are important there, just as they are here. But they've just got another level again of some other types of climate extremes and climate threats. And in some cases, it's kind of an existential kind of issue where the country or parts of it just won't be there anymore unless something happens. So yeah, it's really important that we realise how vulnerable some of our neighbours are to climate hazards and climate change.
And a question around technology. How has the state of technology changed in the past few years for climate measuring and monitoring? And what new and emerging technologies are you most excited about?
Yeah, so I mean, technology gets better all the time, and so for measuring, there's really nice new measurement platforms like Argo floats, which are kind of buoys that go out in the ocean and take measurements and then send the data back by satellite. And that's expanded the amount of ocean observations of the surface and importantly under the surface of the ocean hugely since they came about in the early 2000s. The satellites get better all the time. So the Himawari 8 satellite, you can see some of that as a feed through the Bureau of Meteorology site, and you can see some of the latest imagery there, and that's just amazing compared to what satellites could do even 20 years ago. Weather stations have got some technology developments over time, but have stayed relatively the same. And I think it's also really important to kind of support the Bureau of Meteorology to keep those weather stations going, because we've actually got fewer stations than we once had. So stations are still a really important part of monitoring weather and climate, and we should support them. In terms of kind of data analysis and modelling, that's just taking leaps and bounds all the time with how well we can model and simulate weather processes and climate change processes in models, and with what kind of resolution and what kind of skill. So there's still really hard challenges in there, but I think our abilities and our technologies are getting better all the time in that area as well.
Great. Now, a question from Ryan. How do the forecasts affect water availability?
Yeah, so we like to try and differentiate like forecasts, like a weather forecast or a seasonal forecast, kind of saying this is the kind of likely trajectory we're on, versus projections, which are almost like kind of future scenarios of change if we follow a particular kind of pathway of emissions, if you know what I mean. So just talking in the kind of projections of future scenarios kind of space, In terms of water, I mean, obviously, persistently less rainfall means there's less water available to use. But it also depends on what happens to evaporation. So evaporation, all else being equal, goes up if it's warmer, but it can be counteracted if there's changes to other factors. And then there's also changes to the vegetation and the land surface. So the overall story is kind of complicated, but I guess the fundamental thing is if an area is projected to become drier, to become just a climatically drier place, then water availability will be less. So Southwest Western Australia, for example, have already been facing this and are taking action like building desalination plants and pulling a lot of water out of groundwater, etc. And they'll have to do that on an ongoing basis to come up with a plan to manage having less water. Places in southern Africa, similarly, so you might have heard Cape Town a couple of years ago was kind of facing a running out of water. And other places like that in the kind of mid-latitudes regions, which are projected to continue getting drier. Obviously won't be every year will be a drought. There's still droughts, there's still kind of variability, but just facing persistently drier conditions means that, the droughts will be worse and, water availability will be more of an issue.
And another question from Shane, are there any areas in Australia expected to experience wet bulb conditions and when?
Do you mean wet bulb globe temperature, like as a measure of heat stress on people? Is that?
Yep, Shane is nodding.
Yeah. So this is a really important aspect of heat extremes. Is obviously heat is stressful, but when it's combined with high humidity, it can be really damaging to people's health, and you can get to kind of thresholds where people can't really do anything anymore, and then also thresholds where people just die. So I mean, there's kind of projections under bad case scenarios where parts of Northern Australia get very challenging indeed. When there's adaptations you can do to that, like have places, technology like air conditioning and whatever, where you can kind of cope to some extent. But parts of Northern Australia under some of the worst case scenarios of the future really face some extraordinary challenges with heat extremes for human health and ecosystem health and other animals as well.
Now, obviously, this State of the Climate report was co-developed between CSIRO and Bureau of Meteorology, and you're a lead author of the upcoming IPCC report. What's the national and international collaboration scene like for climate measurement and monitoring?
So climate measurement and monitoring specifically, I mean, people have got their responsibilities and we're all getting on with the job. So Bureau of Meteorology maintain a station network and various other things. And I think there might be one person from the Bureau of Meteorology lurking on the call maybe, and they can add to this. And CSIRO have got their kind of set of kind of activities as well to do with the ocean and Cape Rim monitoring and various things. And that's jointly with the Bureau of Meteorology. In terms of climate research and then how those monitoring and measurements join up to international networks, and then we can kind of use those data sets to do research with and then share data and share information. And there's always been a pretty good sense of cooperation, I think, globally in this area. Maybe compared to some other areas where there's a bit more kind of, turf wars going on. So it could always be better, I think, but I think there's a real sense that the international community need to share data because we all get more out of it if we all contribute to the one set of information. But there's also still a role for competition. So, who can kind of, get the next big scientific paper that makes a discovery using that data is still, of course, a big issue. But I think the sharing is pretty good. I mean, I think it needs to be supported by public good funding because some of these things are just never going to be commercial. And I think that's important that everyone kind of realizes that. But then certain other things can then kind of, into kind of private industry arrangements, etc. But I think, the role of public good measurements, monitoring and research is really important in this area. It needs to be supported.
Now, a question around tropical parasites. Does CSIRO do any work on how Australia might be affected by the movement of tropical parasites, such as malaria, dengue fever, south as the climate warms up?
Yeah, I don't know a lot about this, but I know a little. So, mosquito-borne diseases like malaria, etc., and dengue fever, there was obviously kind of a concern that the envelope or where mosquitoes can be, or mosquito disease-carrying mosquitoes could expand. And I think there's some work done a little while ago, kind of saying, oh, look, just if they expand with the temperature kind of envelope, then a lot of new areas will be vulnerable. I think some work since then has kind of shown there's a few more complexities to it than that, but I think it's an ongoing area, I think, of research and of potential concern that the area of where malaria kind of carrying the mosquitoes could expand. But yeah, I think it was a case of, yes, look, this looks really bad. Oh, hang on, there's some complexity, but I think the full story is still being worked out. But it's not my area of specialty, so don't quote me on that.
We won't. Now, you've mentioned some of like the new and exciting technologies that are sort of coming online. But is there much difference in terms of the most recent State of Climate report compared to the previous editions, maybe from a sort of methodological or approach perspective?
So I've only been involved in the 2018 and the 2020 ones. I wasn't involved in the previous ones, but just commenting on those two. I mean, the kind of format and content and a lot of the main messages are very, very similar, because a lot of the focus is on putting the focus on the long-term context and recent events in a long-term context. So that long-term context hasn't changed a lot in the last few years. We obviously had events that come along, all the time, but then the fact of the things changing as we've been talking about, sea levels, temperature, carbon dioxide, all these things, the trends have been very clear for a long time. So it's just kind of ongoing changes. But yeah, it's still really important to put things into context. And there is also new areas of research and new areas of focus all the time. So maybe 5 years ago, no one would even know the term marine heat wave. And now I think probably maybe most people know that term and know that they're important for, there was one off the coast of Tasmania in 2017, which, led to a lot of kelp and other kind of ecosystem impacts and aquaculture impacts, and that was there all summer. There's a marine heat wave just all summer, and that put it onto the map for a lot of people down around here. And then also people knowing about marine heat waves are a big contributor to coral bleaching. So people know that periods when the sea surface temperature is raised is an important thing. So yeah, I think that there's kind of developments, but the main story hasn't changed a lot.
And perhaps a final question. We've got a question, is it all negative? Can you see any positives or opportunities for Australia from the evidence, perhaps, for the general public or the audience tonight?
Yeah, so I mean, talking about all this kind of stuff, it all does sound like, oh, look, all these bad things are happening, and it's leading to these bad impacts, and it's pretty bad. And it is important to kind of counter that a little bit with a bit of, looking for the optimistic or the kind of solutions, I guess. I mean, I think you can't kind of say that, oh, these aren't a problem. So it's not a matter of not saying, but I think there's some opportunities in terms of, if we can see some opportunities through addressing solutions, then I think that can be exciting. So getting on making the most of opportunities from changes to the energy industry and new opportunities for new technology or new ways of doing things. I think that's exciting and interesting and can be kind of a source of kind of enthusiasm. I mean, there's very limited cases where the actual change in the climate will lead to new opportunities, but there are some. So, for example, areas that were previously not available to do some things will be. So people can grow different varieties of grapes where they couldn't before, for example, and agriculture can change and in some ways have some new opportunities. Things like that. So there's limited opportunities, because of the change in the climate, but I think there's a lot of opportunities and a lot of source for, energy in terms of, grasping kind of some of the solution side.
Yeah, great. Well, Michael, a very big thank you to you for taking us through the latest State of the Climate report, including the latest climate science. I know I've thoroughly enjoyed this discussion and learnt a lot. Now I'll pass everyone back to Andy to close tonight's webinar.
Thanks, everyone.
Thank you. I'd like to point out to everyone too that being February, we've currently got the Sustainable Living Festival happening largely online, I'm sure now, right throughout February. And they talk a lot about different opportunities for ways that we can sequester carbon and new technologies. And I was listening to a very interesting event on that last night. And I know the soils was we've got great potential there, and if people want to get a bit of an introductory thing, go back and look at our webinar from last year on that. But on that note, stay tuned for further webinars. We're going to be running these bi-monthly, and the general idea is to have them on the third Wednesday of the month. I can't tell you what the next topic is yet, that's to be announced. But I'd also like to give a little plug now for YCAN here. If anybody likes more information about what we do and to either receive a copy of our bi-monthly newsletters or come along to our monthly meetings, please make contact with us via our website. There's a pop-up window that comes when you open that up too. And our meetings are held on the second Wednesday of the month, either on Zoom or, in the good old days, we used to hold them at the Carlton Neighbourhood House, and hopefully one day soon we might do that again. Thank you for all your time this evening, and I'm trying to find my other running sheet. Yeah, but with all of that, I'd like to thank you all for your attendance. We had a good number of people here tonight, and hopefully we'll see you at a webinar in a couple of months. Thank you. Bye, everyone.
Oh. Is he gone?
I think Michael's gone, but I can
Yeah.
yeah, contact him later. Thanks. Bye.
Sarah, is there a way to actually automatically disconnect people apart from maybe just the core or just the core of us after a session has concluded?
Yes, let me. I think they're naturally leaving. Yeah.
Yeah. Yeah, because it does feel a bit kind of weird sometimes when we have
yeah, that's right. Sorry, I'm not sure about the last person.
suspect the last person's just gone away and left.
Yeah,
Possibly,
go and have a cup of tea.
Yeah.
I can remove, but
Oh yeah, do that.
Yeah, that's. I think they do that. Yep.
Can I do that?
Yep.
Yes.
Oh,
Please. I don't think they'll be offended.
There we go.
it's standard Zoom practice, is it? Yeah.
Yeah.
Well,
So
what we could also do if we wanted to avoid this in the future is we can all leave, but then you can log back in using the same link.
Yeah. So sorry, I muted you in the middle of your introduction, Andy.
Oh,
that's
no.
fine. I just thought I'm doing the welcome to country. I can't just do half of that. I've got to do that one right.
I could hear somebody, somebody's budgie or something.
Yeah, no, I thought they were talking to a kid or something, like about toast or something.
Yeah.
And I was like, oh, poor person. But I couldn't see who it was. Like I was trying to like see.
Yeah.
Did you manage to record it, Sarah?
Yes.
Oh, great.
I'll stop it now.
I think it's still recording.